Hey guys, how's everything going? This is JSer who is not good at algorithms. In this video, I'm going to take a look at 6 to 1 task scheduler. We're given a character array representing tasks. It contains capital letters A to Z, so it's finite, where different letters represent different tasks. Tasks could be done without original order, okay? Each task could be done in one interval. For one interval, CPUs could finish one task or just be idle. However, there is a non-negative coding interval n. That means between two same tasks, there must be at least one intervals that CPU are doing different tasks. So same task could not be too close. I need to return the least number of intervals the CPU would take to finish up all the tasks. Like, let's analyze the input like this. And with the cool time to be 2, so there must be at least 2 elements between two same tasks. Well, for this example, it's gonna be obvious, right? A. Let's first place A, then we put B among A's, right? It will be good. Be good enough. And then, of course, that at least to 2, so there must be one idle. We use 0 to mean the idle. So it's the result 8. So what does this example mean? It means that we actually could do some interleaving, right? Let's say if the example is like A, B, 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 because A has the most account. If we put A first, actually there will be what? There will be 3 empty space, right? We can put in, right? And according to the previous one, actually there will be 4 space widths we could use to place the rest numbers. Now these numbers, at least suppose that the n is 2, there will be like 2. If we call this a bucket, the bucket must has to empty space at least, right? This one is different because this is last one. Let's first ignore it. Now let's place B. Well, a good thing is that if we do place the new digits, like new tasks, one by one for each bucket, it will generate just the right space, right? If we put B here, next B, it's not gonna be too close. So this gives us the idea that we could just place the tasks which has the largest amount, and then create this bucket, and then place the rest task one by one. So for the tasks, if the tasks could be put into these 3 buckets, right? It's just be put there, right? It's not gonna be a big problem, right? It's like we just put here. If for B, like 3B here, we put 3C. Because A has the largest amount. For the rest, the worst case is that the B or C has the same amount. If for that case, we couldn't put them into these buckets because they're gonna be, with a drawer theory, there must be 2 B at the same bucket. That's not good. We could put B at the last bucket, right? Yeah. If it is not that, it's one less, you could put C here. Or if there is a D and then D, just 2, it's okay. And now we have E. If there's 3E, E, and then E, and then E. Right? Because even though the E for each bucket is at different index, but the distance will not change because the 2 E's here will only get farther, right? Because the amount will only be 1 less. So no matter, just like think about the Tetris, no matter what the horizontal line no matter which layer it is, they will fall, covering the whole, like they will not overlap. So it's not gonna be a problem. So the only problem would be the numbers which have the same amount of A, right? Like B, right? What if you say that you might think, what if we put like for B here, right? What if we put the B here to C, D, B, E, like here? We could be put here without last one. It is okay. It is okay, but actually it doesn't make the difference for the last. We're going to retrieve some least numbers of intervals, right? It doesn't change the intervals. So why? Because, so suppose, okay, the only thing that we could move B and reduce the interval is that the original position, it will be idle, right? Like this, right? Like B. Originally, like B put it here, and there was idle. That B could be placed. B could be placed there, right? Like let's say if idle is like this. If there is this idle, what will happen? Is it possible that there is an idle like this? Like if there is idle like if there is an idle, it must be that this is still within the required, right? At least n. So if there is an idle here, then it must be still within this distance of n. So B could not be placed there. You could not place two B's into the same bucket. So if there is no idle, it doesn't matter, right? Because if you put even if you put B here, it doesn't make the idle lesser. So we could forget about that. So now the things become clear. Remember, we only care about what number has the most occurrence, and what's the rest numbers, and the rest numbers which has the same occurrence, right? Like here for A, B. Well, you think A and B is the same, we could think that these are groups, right? These are the groups, and then these just handle the A, B's, right? If we target how many special cases like A, B's are, we can calculate the rest length. And because this is fixed for the required intervals, right? We can compare the length here against the length necessary intervals count, right? If it is lesser, or bigger. If it's lesser like this, well, the length of this could be just calculated with the amount of A, right? With the n. This is fixed. And the slot, if there is no idle, which means the count of letters will be larger than the idle, than the possible idles. We can detect that case by subtracting this with the task length, right? If we get the length of this, we could know what the count of this, right? And then compare it and get the maximum. Cool, so that's our answer. We will get count of each task as we did before in a previous video. Please search on my channel. There is something called what? I forgot. It's what? Let's see. There's a problem. Oh no. Which one? Reorganize string? Yeah, this one. Please search on my channel for 767. There is a detailed explanation. Okay, let's count the task. We're told that the tasks are capital letters, so it's finite. We create an array counts of tasks. New array 26. Fill them with 0, and then we'll start counting. At the same time, we need to get the max count. We subtract the letter to capital A to get the index, which would be task cact code at 0 minus code for A. So count of task index plus 1. If it is bigger than max count, we update it. Okay, now as we said before, we found determine how many tasks are to the max count to detect the length here, right? Now we could just do the calculation. So as we said before, we get the task count of max count is which is here. So we get how many the minimum account required by the interval, right? Required by n. Interval requires, I think, equals what? Equals max count. Max count is a, right? Minus 1. Times what? Times the length like this. This would be n plus 1. Plus the rest 2, right? And if we put all the tasks, there might be a case that all the idles could be replaced by real tasks. So we need to do comparison, right? Compare this minimum one versus the real task length, and the bigger one, of course, wins, right? Let's run the code. Cool. Submit. Yeah, we're accepted. And let's analyze the time and space complexity. Time, this one is linear, this one linear, yeah, so it's linear time. Space, we use an extra array to keep track of the count. It's linear. It's not linear, so 26, yeah, so it's constant. The one thing is that what if we are asked to generate the final result, right? Like this. Well, it's simple, as we said. We're just following the idea here. We could create a bucket like 1, 2, 3, 4, right? Create 2 arrays, and then for each task, we just put them into the bucket, right? We put them first into the first 3 bucket, and then if the count is bigger than it, if that is equal to the max, we put it into the last bucket, and then finally we join them up, right? Yeah, let's try to do that. I'll create another one. To return a real task sequence. Cool. Now you see we get the account here. We just need to do some slight changes here, right? Cool. Now create 4 bucket to collect the result. The 4 bucket is like this, right? We create 4 bucket, not 4 bucket, but max count bucket. Okay. Now for each number, for each task, we will push them into the bucket. We start with A, right? Something like here for A. And for each letter, we'll just put them to the bucket one by one. Let's keep track of the bucket. We first set to the first bucket, and then if count of task I is 0, that means there's no task. We just continue, right? And then we could get the count equals count I. Cool. Const task equals string from character code I plus code for A. Yeah. Now let's try to put the task into the bucket, right? So while the count is still big, there's still count. We put the task one by one. We put to the bucket. There's a problem that if the task count is if the count is if the count is bigger than it, then we need to set the last bucket. If not, we put the top 3 buckets, right? The buckets except the last one. So, okay, first we push to the buckets. pushed bucket, no, push task. But current bucket will move to the next one, right? Well, here is a problem, right? We need to actually mod the bucket length. But if the count equals max count, if it is max count, okay, no, if we say if it is max count, then we will say if max count, definitely it's gonna meet the index here. So if current bucket is bigger than max count, this is max count, so the index max minus 1. So if it is bigger than this, no, wait a minute, max count like is 3, 0, 1, 2, 3. We can't set it to 3. So if it's bigger than it, wait a minute. Yeah, it's okay. So if it's bigger than max count, we will set it to 0. If it is not, we check. If it's bigger than max count minus 1, we set to bucket 0, right? Let's try to log the bucket. I'm not sure whether I'm getting it right. AB, AB, AB. Oh, cool. What about A, B, and C, D, E, F. We get A, B, A, B, A, B, and C, D, E. This is something wrong. We should not set E here. Well, this is the next bucket. And we push it. Count equals max count. Three. This is 2, 0, 1. My bad. This is bucket length, right? Shit. Still not right. Current bucket. Bucket length is 3, so 2. If it is bigger than 2, we move it to the left one. Shit! It should be minus 2. This should be right. And the bucket length is max count. Cool. Where is A? A. Why A here? Oh, let's console log task buckets. AA. Count bucket. Bucket A. Task is A. Okay, count is 3. Yeah. And current bucket is 0. We push to the A. Because A, the count is max count, right? Yes, and the current bucket +1. Next bucket. I think I think we should not check the next bucket, but we check it here. If it is maximum, and then current bucket is bigger than bucket's length -1, then we move to first. For the other cases, if it is the bigger than it's farther than the last one to the right, then we set it to the big and then move it. Oh, this should be right. Still not right. What? Why? Oh my baby, I know what happened. We should compare the count of task I, not count. Uh-oh. Yeah, this is good, right? You see, for A, B, we are setting them to all the buckets, but for C, E, we only to the first 2. Cool. So now we're handling the right bucket. Now let's get collect the result. Fill the buckets with idle except the last one. Why? So for let I smaller than bucket.length I++. For each bucket, for the previous, except the last one, right? And if buckets length is smaller than n, then we need to push the idle, right? We needed to push this amount of idle. So while count is bigger than 0, count -1, buckets I push idle. Got. And finally, we return buckets join result push buckets I, and then push enough idle, and finally we result join this arrow. Let's see what happened. A bucket's not. But to result push. We console log. Nothing? We buckets. God, we should do this. Yeah, now we get you see there is no idle. If we pass the original input A, B, and A, B. What? God. Because we're counting the max, the first task, right? So it's not, should be not n like this. This is n, so the group of bucket should be n plus 1. So this is bucket, n plus 1 is 3. So here should be n plus 1. Cool. Now, yeah, you see, we get the result like AB idle, AB idle. It's the same as, oh, where is the last AB? My bad. Last is not, should not be filled, but need to be pushed, right? Plus minus 1, and this should work, right? Okay, so yeah, that's all for this problem. Hope it helps, guys. The basic idea is that create buckets and then put the task or letters one by one and move to the next bucket. The only thing we need to take consideration is the last bucket, right? We only put the task which has the maximum occurrence in it, right? And if we're going to just return the amount, return the number, we can just do directly by this calculation. But if we want to return, if we are required to return the final result, like the path like this, we just follow the same idea. We create buckets, create real buckets, and push the tasks. Pay attention to the special case of the maximum account, and then we collect the result from bucket, but fill the bucket which is not full according to our requirement. There must be at least depth of n. Yeah, that's all for this problem. Hope it helps. See you next time. Bye bye.